In this lesson, you will learn how to use the method of linearization to approximate the values of functions at specific points. The basic idea of linear approximations is that sometimes we can approximate complicated functions with simpler ones, like lines, that give us the level of accuracy we want for a specific application. As you know, if we have a function f of x, we can find the equation of the line tangent to that function at a specific point, for example, a, f of a, by finding the derivative. Once you have the slope, the equation of the line can be written in point-slope form. It would look like this. Y minus f of a equals f prime of a times x minus a. And if you reorganize by adding f of a to both sides, you'll get y equals f of a plus f prime of a times x minus a. If y is a linearization, you will see it written like this. L of x equals f of a plus f prime of a times x minus a. At a specific point, the linearized value for x is approximately equal to f of x. And you can see why this is true by looking at this picture. You have a curve, y equals f of x in black, and you have the line tangent to that curve at a specific point where x equals x naught. That's the red line. And you can see at the point x naught, the y value for both the original function f of x and the linearized function are approximately the same. And we're going to call this linearized function L of x for clarity, as opposed to calling it, say, y. All right, so let's look at an example. Suppose my original function is the square root of 1 plus x. I'd like to find the linearization when x equals 0. If I'm going to do that, well, first off, when you're asked to find the linearization, you're simply writing the equation of a tangent line. And to do this, you're going to need a point and a slope. In this case, f of 0 equals 1, so the point is at 0, 1. To find the slope, I need to find the derivative of the original function, which I've just done. And then I'm going to substitute a 0 in for x, and I'm going to find that the slope is 1/2. And so now I have the point and the slope, and I can go ahead and I can write the equation of the line that's tangent to the original function at that point. And if I clean it up a little bit, I end up with L of x equals 1 plus x over 2. All right, here's one for you to try. I would like you to find the linearization, L of x, if the function f of x equals minus 2x squared plus 5x plus 10 is close to the point where x equals 7. So this is multiple choice. So I hope you picked C. L of x equals minus 23x plus 108. Here's one for you to try. F of x equals 4x squared minus 4x minus 11. Find the linearization when x equals 3. So when x equals 3, f of 3 is 13. The point I'm going to use is the point 3, 13. I need the slope, so I'm going to find the derivative of the original function, plug 3 in for x, and I end up with a slope of 20. And therefore, the linearization is 13 plus 20 times x minus 3. And if you clean that up a little bit, you're going to get L of x equals 20x minus 47. Now we're going to use what we just got to approximate the value of this function when x equals 3.002. So the linearization was created when x equals 3, and it's useful for when I'm looking for points that are near 3, and 3.002 is very close to 3. So L of 3.002, I'm just plugging it in for x, and I get 13.04. What's the actual value of f of x when I plug in 3.002? Well, it's 13.040016. My function, my linearization, does a really good job of approximating the value of that function at the point 3.002. All right, you try. Find the linear approximation for the function f of x equals the square root of 1 minus x when x equals 0. All right, so first off I need the point. Plug x equals 0 into the function and you'll get the point 0, 1. Then you need the slope, so you have to find the derivative, put the 0 in for x, and the slope is negative 1/2. And therefore the linearization is going to end up to be L of x equals minus 1/2 x plus 1. All right, let's use it. You just found the linearization for this function was L of x equals minus 1/2 x plus 1, and this is for values close to 1. So what if I'd like to know the square root of 0.9? It's pretty close to 1. Well, x equals 0.1 will give you that value. So I would like the linearization at 0.1, and I end up with 0.95. So the square root of 0.9 is approximately 0.95. How close are we? Well, it's actually 0.94868. We're pretty close. All right, here's another one for you to try. Still using f of x equals the square root of 1 minus x. You've got the linearization, which we already computed. I'd like you to use it to approximate the number, the square root of 0.99. All right, well, this time I'm interested in an x value of 0.01, and f of 0.01 would equal the square root of 0.99. So I'm going to go ahead and plug in the value into my linearized equation, and I get 0.995. Well, what's the actual square root of 0.99? It's actually 0.994987, very close to 0.995. All right, here's another example. I'm going to use the method of linearization to estimate the values of cube roots for numbers near 125. For example, the cube root of 122. Just to remind you, cube root of x can be written x to the 1/3 power. And I'm interested in values near 125, so I plug in x is 125, I get 5, and therefore the point I'm going to use for my linearization is 125, 5. I find the derivative of the original function. I'm going to use that to find the slope. Plug in 125, and I get 1 over 75. And therefore my linearization, L of x equals 1 over 75x. I do a little maneuvering around, combining like terms, and I end up with L of x equals 1 over 75x plus 10/3. All right, so we're interested in the cube root of 122, so I'm going to use my linearized value, plug in 122, and I get approximately 4.959999999. The actual value is 4.95967,566. It's a very good approximation. And that's it. This is the last bit of notes for this course this year. At this point, you should log into ClassKick and do the assignment called Math 603, 3.8 Linearization Practice. Congratulations, we're almost done.